In this lesson, we are going to learn how to calculate the standard cells potentials of an electric cell, which consists of voltaic cells or electrolytic cells. Now, voltaic cells could be galvanic, or electrolytic could be electrochemical cells. So those are the possible electric cells. So let's look at an example problem before we look at the equation. Here in most problems, it will give you two half cells, and they are both in reduction form. How do I know? Because the electron is being gained on both of the half cells. So you are giving two half cells in reduction form, and each of the cells come with specific standard reduction potentials. Based on the values of the reduction potentials of two half cells, you can apply to the equation and solve for the standard cell potential. Now, what is that equation? That equation is right here. Standard cell potentials, which represented by E, is equal to the standard oxidation potentials plus the standard reduction potentials. Wait a minute, how do we get the oxidation from the reduction? To determine which of the two half cells is undergo oxidation, we need to review the fact that a substance with a higher standard reduction potential would undergo reduction, where a substance with a lower standard reduction potential would undergo oxidation. So here I have the two values. Which one is going to be lower? And of course this one is lower. So therefore this one will undergo oxidation. So what does that mean? When this undergo oxidation is the opposite of reduction, so therefore the potential oxidation would be the opposite of reduction. If this is negative 1.66 volt, the opposite would be plus 1.66 volt. So there you go, you have your oxidation values. So we just plug into this equation, which is equal to, our oxidation is 1.66 volt. Of course, the other half cell would be reduction. In this case, would be negative 0.44. So we add negative 0.44, and that turned out to be 1.22 volt. And the 1.22 volt, that would be your E cell. So 1.22 volts equal to your E cell, which is your standard cell potentials for this voltaic cell system that consists of this half cell and this half cell. In this problem, I have two half cells. We have nickel 2 plus 2 electron equal to nickel solid, and it has the standard reduction potentials of negative 0.26 volt. And how do I know it's reduction? Because the electron is on the reactant side, that means gaining electron. And then the other half cell is, we have Ag plus 1 electron equal to Ag solid, and it has the standard reduction potential of 0.8 volts. So which of the two is your oxidation? Again, the lower standard reduction potential undergo oxidation. So this one is lower, so therefore this is going to be oxidation. Since oxidation and reduction are the opposite, therefore you have the E cell of oxidation would be the opposite of reduction, which is the opposite of negative 0.26 volt. Therefore we have plus 0.26 volt. Then we plug into the equation of standard cell potentials to find the E cells of this voltaic cells. According to the equation, is equal to the standard oxidation potential plus the standard reduction. So our oxidation is right here, which is 0.26, and then our reduction stays the same, so we add that to 0.8, and that gives us 1.06 volt. And there you go. That is our standard cell potential for this two half cells. Here we have Au 3 plus 3 electron equal to Au solid, and it has the standard reduction potential of 1.5 volt. Then we have Ag plus 1 electron equal to Ag solid, give us the standard reduction of 0.8 volt. So again, going back to the rule, the one with the lower standard reduction potentials will undergo oxidation. In this case, this will undergo oxidation. So if this is oxidation, cell oxidation, would be the opposite of reduction, give us negative 0.80 volts. And then we can just plug into the equation for the standard cell potentials, which in this case is going to be negative 0.80, and we plus the reduction, which is this one, 1.50, and that would give us 0.70 volt. And there you go. That is our standard cell potential for these two half cells.